if I write a number, so a number is written x to the power a. X is called base and a is called power or index. Okay. Now there are certain laws which govern how we deal with such numbers. Law number one, if bases are same and they are multiplied, if bases are same and they are multiplied, powers would be added. So x times x will be x squared. Similarly, if I multiply x cubed with x to the power 2, the answer will be what, Miss Noor? X cubed times x squared. What's the answer? Miss Noor? Miss Aisha, what would be the answer? X cubed times x squared. X to the power 5. Okay, so this is law number one. Acha, just on a side note, we do not confuse it with if I am multiplying, sorry, if I'm adding x plus x, it will give me 2x. If I'm multiplying x and x, it gives me x squared. Okay, similarly, if I have got x cubed times y squared, now the powers they wouldn't add y because bases are different. So the answer for this one would be x cubed y squared. Okay. And if I were to add something, so for example, x cubed plus x squared, these two numbers they wouldn't add, they would stay separate, they would stay as x cubed plus x squared. Okay, and this is not equal to x to the power 5. These numbers they're not, so we have to know a clear distinction between what's the rule for addition and what's the rule for multiplication. Only when we are multiplying the numbers, number one, and secondly bases are same, only then powers would add. Okay, is this clear, Miss Aisha? Okay, the next thing is if I have got x, so this was rule number one, if bases are same, powers would add. Rule number two, if I have got power on top of a power x cubed and then that thing is squared, now the powers would multiply. Power on top of a power, powers multiply, so the answer would be x to the power 6. Okay, similarly, if I've got y to the power 5 and then I take cube of that, it will be y to the power 15. So power on top of a power, the powers that multiply. Is this clear, Miss Noor, Miss Aisha? 2x plus x will be 3x because the thing that we are adding are x's. So if I write over here 2x plus 3x, you say 2x 2x plus x. So there was one, I mean x, there are two x's and then there is another x. So I add them all up, it would give me 3x. It will be 3x. No, it wouldn't be. Why? Because they are not multiplying. 2x plus x is not okay. Let me write over here 2x plus x g. 2x plus x is not equal to 2x times x. There's a difference. For the first one, answer will be 3x. For the second one, answer will be 2x squared. If it's in the second case, this is multiplication, 2x times x. Yes. Understood? Okay. Ms. Noor, any questions? Ms. Noor, we can't hear you. Any questions? All right. The next thing is if I have got y to the power 5 divided by y to the power 3. Now the rule is, if there is, this is a fraction. In fraction we have got two parts, numerator and denominator. So now what we will do is, if we are moving anything from the denominator to numerator or numerator to denominator, signs of the power would change. Okay, so this thing, it will become y to the power 5 multiplied by y to the power minus 3. Okay, if a value from the denominator it goes to numerator, the sign of the power it would change. And now, if now both values, since they are multiplying with each other, bases are same, powers would add. So 5 plus minus 3, which would be 5 minus 3, and the answer will be y squared. Okay, another example, if I have got uh, x to the power 15 divided by x to the power 24. Again, same rule, denominator, I will move it to the numerator. So it will become x to the power 15 multiplied by x to the power minus 24. Now bases are same, numbers are multiplying, so powers would add 15 plus minus 24. It would be 15 minus 24, and the answer would be minus 9. So it will be equal to x to the power minus 9. So I can leave it like this, or I can move this x back to the denominator, and it will become 1 over x to the power 9. Now because it is moving from numerator to denominator, again the sign of the power it would change. Whatever the sign is, if I'm moving from numerator to denominator or from denominator to numerator, the sign of the power would change. Is this clear, Miss Aisha? We'll practice more questions on this. This is just me giving you the rules of what's about to come. Understood? Acha ji. So we have discussed three basic rules. Rule number one was, if bases are same and the numbers are multiplying, powers would add. Only if bases are same. Only if bases are same. And we have already discussed what's base and what's power. The next rule was, if there is power on top of a power, powers would multiply. And the rule number 3 was, if we have a fraction and we move any value from numerator, the numbers they're dividing, the numerator, if I move it to denominator, or denominator, if I move it to numerator, the sign of the power would change. Understood? This same question, the last example that I gave you, x to the power 15 over x to the power 24, there was another way I could have done it. Instead of moving denominator to numerator, I could have done x to the power, sorry, I move numerator to denominator. So what's left in the numerator, it would be 1, and it would be x to the power 24 was already there, multiplied by x to the power minus 15. And now two values, they are multiplying in the denominator, bases are same, powers would add. So 24 minus 15, it would give me 1 over x to the power 9. Same answer. Same answer. Excuse me. Sorry, again, I didn't get your question. For both the cases, the values, they are multiplying with each other, whether in numerator or in denominator. Values among themselves, they are multiplying. Well, sure. Let's say that we have um, x to the power. What should I give power in the numerator? Any number. Give a number. Acha ji, if I have, okay. Here is an example. Here is an excellent example. Okay. If I have got 125 divided by 125. What's the answer? On your calculators, check. 125 divided by answer 5. Now I will get the same answer using the laws of power. So the laws of power, they say 125 is 5 to the power 3. Check on your calculator. 5 5s are 25, 25 5s are 125, right? So I can write it as 5 to the power 3. Similarly, 25, I can write it as 5 to the power 2. Okay. Now numerator, if I move it to denominator, if I move it to the numerator, the sign of the power would be negative. So 5 cubed multiplied by 5 to the power minus 2. And this would give me 5 to the power 1, which is 5. Understood? So whether it is numbers or it is variables, the laws, they stand. These laws, therefore, the power and basis, they would stay true. Okay. One more thing. Uh, a good time to know that x to the power 0 is not equal to x to the power 1. Anything raised to the power 0, because x to the power 0 answer would be 1, and x to the power 1 answer would be x. So for example, if I have 125 divided by 125, why do I get answer as 1? 125 by 125, what would be the answer? 1. Can I prove that using the laws of power? Yes, I can. How? I say 125 to the power 1 multiply by 125 to the power minus 1, the one that I moved from the denominator up to the numerator. So it gives me 125 to the power 0, which is 1. Understood? Okay. So even when we don't know, I mean, in the subconscious, we have already been using this law, and it stays true. It stays true even for numbers or for variables. Now let's practice some questions. Mm, there were three that we used. G. We've used only three. For the third one, we just said whether we are moving the number from the numerator to denominator or denominator to numerator, the sign of the power would change. Okay. Now questions on it. Acha ji, questions. Acha, let's quickly do these. Hmm. Bismillah. Acha ji, question number 1. Using indices, simplify the following expressions. So following numbers, we have got a few numbers multiplying with themselves. So using index, how we can express the same number? 3 times 3 times 3. It is the same as saying it is 3 cubed, right? So I can write this as uh, 3 to the power 3. Okay. Similarly, for 2, 2, 2, 2, 2. So there are 5 2's which are multiplying with themselves. So it would be 2 to the power 5. Understood? For maths, it is essential that we understand what things they are equal to each other and what things they are not equal to each other. That's also what we must know. So here is a good time to notice that 2 to the power 5, it is not the same as 5 to the power 2. Because 5 to the power 2, that would be 25, and 2 to the power 5, what would it be? 2, 4, 8, 16, 32. So it would be 32. Acha ji. Similarly, for question number 4, if I quickly solve it, what would the answer be? For question number D, what would the answer be? 6 to the power 4. For question, doesn't make a difference. Doesn't make a difference. Okay. F would simply be 5 to the power 1. It would stay as it is. And E, what would be E? 1, 2, 3, 4, 5, 6. There are 6 8s multiplying with each other, so it would be 8 to the power 6. Understood? Okay. Now, using the law of simplify the following using the law of indices. So what we do, there are 3 2's multiplying with each other and 2 3's. So it would be 2 to the power 3 multiplied by 3 to the power 2. Okay. So 2 to the power 3 is 8 and 3 squared is 9. So 8 times 9, which is 72. Right? Okay. Over here, what have I got? 1, 2, 3, 4, 5. All right. And what's 4 to the power 5? What would be 4 to the power 5? 1024. And what would be 5 to the power 2? Wrong, wrong, wrong. 25. Remember, Allahu Akbar. Um, 5 to the power 2 is not equal to 5 times 2. Okay, because this would be 25 and that would be 10. They're not equal. Acha ji. And now the final step, 1024 times 25. Excellent. Question number C, if we can just do C and F. So first step would be, and the answer is 3 to the power 2 would be, okay, and 4 to the power 3 would be, and 5 squared would be, so the answer is 14,400. 2F please. G, and that will be equal to, and 4 squared is 16. So the answer would be, all right. Acha ji, moving to the next question. So let's just do question number 4, part G and H. G, how would we do it? Mr. Arman, question number 2, part G and H. What would be the answers? 4, 4. G and H. G, the same way. Mr. Arman, question number 4, G and H. What would be the answers? You don't use calculator for this one. For 10, here is another rule. 10 to the power something will always be equal to 1 followed by that many number of zeros. So 10 to the power 2 will be 100. 10 to the power 3, 125,000. 10 to the power 3 would be 1000, 1 and 3 zeros. 10 to the power 4 will be 10,000, 1 and 4 zeros, and so on. Acha, since you have understood this question, how about you people give me the answer in the form of index? In the form of index for question number D, F, sorry, F, G, and H. Question number 1, 7.2. F, G, and H. You could leave your answers in the index form. Question 1, F, G, and H. If you could type your answers, hmm, index form, in the power form. You don't have to convert it into the decimal, the whole expansion. Just leave it in power form. Not the full expansion of it. Leave the answer in index form for F, G, and H. 3 to the power 2 times 3 to the power 4. Bases are same, powers would add, so the answer would be 3 to the power 6. B. 8 to the power 5 times 8 to the power 2. Bases are same, powers would add, 8 to the power 7. Sure. GG. We are simply using the law of indices that we have mentioned at the start. Sure. Control V. So for the first one, the numbers which are multiplying, bases are same. So the numbers are multiplying, we would simply add their powers. So it would be 3 to the power 2 plus 4, which is 3 to the power 6. 8 to the power 5 times 8 to the power 2. Bases are same, powers would add, it would become 8 to the power 7. Similarly, 5 to the power 2 times 5 to the power 4 times 5 to the power 3. Bases are same, powers would add. 2 plus 4 plus 3, 6 plus 3, 9. So 5 to the power 9. Again, bases are same, powers would add. 3 plus 5 plus 2, 4 to the power 10. Acha ji. And then this one would be simply 2 to the power 4. Okay, here it gets interesting because there are different numbers. Threes, they would multiply among themselves and their powers would be added. So it would be 3 to the power 2 plus 3, 5. And sixes, they would multiply among themselves. So 6 to 6 multiplied by 6. 2 plus 4, 6 to the power 6. So it would be 6 to the power 6 multiplied by 3 to the power 5. I mean, you can do further expansion of it and solve it in your calculator, but now just to the point that we are trying to get across is which numbers would multiply in what way and how would their powers add or not add. That is all that we are trying to practice right now. Okay, so over here the bases are 4, 5, and 6. So for 4 base, Power would be 5 plus 3, 8. For 5 base, power would be 5 plus 4, 9. 5 to the power 9. And 6 squared will stay 6 squared. This is for part G. And for part H, it would be 2 to the power 4. Is there any other 2? No. So it stays 2 to the power 4 multiplied by 5 to the power 7 and 5 to the power 3. So it will become 5 to the power 10 multiplied by 6 to the power 2 plus 6, which is 8. And now you can put these values in your calculator and get even the answer further in one decimal form. But for now, we are leaving it like this. Achha, and G, G, sure. Acha ji, moving on to the next question. We have discussed this law for fractions. If numbers they are dividing, 4 to the power 6 divided by 4 to the power 2, the one in the numerator, it goes to the the one in the denominator. If I move it to the numerator, its power sign would change. So 4 to the power 6 multiplied by 4 to the power minus 2, it will become 4 to the power 4. Similarly, if you could quickly solve the rest of the questions, rest of the parts for this one. So 5 to the power 7 divided by 5 to the power 4. 5 to the power 4, once it gets to the numerator, its sign would become, this will be equal to 5 to power 7 multiplied by 5 power minus 4, which is 5 power 3. 6 power 5 multiplied by 6 power minus 2, which is equal to 6 cubed. Okay. Now they're written in fraction form. So again, 6 to the power 5 minus 2. This would be 6 to the power 3. This will be equal to 4 to the power 8 minus 5. Again, 4 to the power 3. This would be 8 to the power 6 minus 5, which is equal to 8 power 1. And this is equal to 3 power 9 minus 2. This will be equal to 3 to the power 7. Any questions in question number 2? None. Okay. Moving on. Question number 3. Question number 3. If there is a power on top of another power, the powers they would multiply. So 5 squared it will become 5 to the power 4. 10 to the power 10 squared to the power 5, it will become 10 to the power 10. So this is the only thing that you have to remember for this exercise, when to add powers and when to multiply them. So this one, it will become 6 to the power 8. B will become, G, what would be the answer for B, D and F quickly? Ms. Aisha, B. Sir, which two numbers? If there is power on top of power, what's the rule? We have to multiply them. So the answer would be 4 to power 12. Miss Noor, answer for part D. Yes, please. 3 to the power 15. Because power on top of power, powers would multiply. Yes, so it would be base 3 and power 15. Sir Arman, what would be the answer for part F? Sir Arman, answer for part F. Yes, Miss Noor? Yes, correct. Good job. Acha ji. Moving forward. Ji. I've already explained you the rule for what does power 0 mean. So if anything is raised to the power 0, it would mean it is 1. So we discussed the example of 125 over 125. Any number divided by itself, why does it become 1? So the reason it becomes 1 is, so for example, let's take another number, 2500 divided by 2500. This is the same as saying 2500 to the power 1 multiply by 2500 to the power minus 1, and this will be 2500 to the power 0, which will be equal to 1. That is why we cancel them out, and right away we know the answer is 1. Okay, so a few questions to test this topic. Acha, similarly, if I have a number written like the number that I have written, it says 4 to the power hmm, 4 to the power minus 5. It will be equal to 1 over 4 to the power 5, because when I move it from numerator to the denominator, the sign of the power would change. Similarly, if I have 1 over 5 to the power minus 7, it will become 5 to the power 7. Also, if I have 1 over 5 to the power 8, it will be equal to 5 to the power minus 8 in numerator. So hopefully this thing is clear. Now you have to evaluate these, you have to calculate answers for these without using calculators. Calculators are not allowed. Yes, please. Go ahead, Miss Aisha. Question number. All right. I'll do question number 1, A, B, and C, and I'll ask you people to do question number D, E, and F. This in this question we'll just be using the rules that we have learned this far. Nothing new. Okay. 2 to the power 3 multiplied by 2 to the power 0. This will be, bases are same, so powers would add 2 to the power 3 plus 0. The answer would be 2 to the power 3, which is 8. Okay. Next part, it is 5 squared divided by 6 to the power 0. 6 to the power 0 means it is 1. So it is 5 squared divided by 1. 5 squared divided by 1, which will be equal to 5 squared or 25. Okay. For part C, if I'm doing 5 to the power 2 multiply by 5 to the power minus 2, bases are same, powers would add. So 2 minus 2, it would be 0. And the answer would be 5 to the power 0, which is 1. Understood? Now, Mr. Arman, if you could tell me answer for question number 1D. All of you, quickly solve 1D and give me your answer. 6 to the power minus 9. Mhm. Wrong answer. Wrong answer. Miss Noor and Sir Arman. Question number 1D. What's the rule that we would use over here? Two numbers are multiplying. Sorry, Miss. Just a second, Miss Aisha. Miss Noor, what were you saying? Yes, please, 1D. Miss Aisha? Bases are same, so powers would add. 3 and minus 3, if I add them, what do I get? 0. So the answer would be 1. Sir Arman, question number 1E. Excellent. It will also be 1. Why? 0 and 2, they would multiply. So 4 to the power 0, which will be equal to 1. Excellent. Uh, Miss Noor, also for part F, what will be the answer? Yes, please. In fraction form? Excellent. 4 to the power 0 would be 1 divided by 2 squared, which will be 4. So that's the answer. All right. Quickly, question number 2A. Miss Aisha, what would be the answer? Leave your answers in fraction form if you have them. 4 to the power minus 1, I would simply move it to denominator and it will become 1 over 4. We usually do not leave negative powers in answer. If I have negative power in answer, I would leave the answer in positive powers. Okay, Miss Noor, question number 2B. What's the answer? Excellent, excellent. 1 over 3 squared, which would be 1 over 9. Sir Arman, question number 2C. What would be the answer? Question 2C, Sir Arman, what would be the answer? 3 over 50. Excellent. So first I will have 6 divided by 10 squared, which is 100. And then if I simplify it, it would be 2 3s are 6 and 250 times 100. So 3 over 50. All right. Miss Noor, question number 2D quickly. What is the answer? Miss Noor, question number 2D. Excellent. So it will become 5 divided by 10 cubed, which is 1000. And then 5 ones are 5, 5 twos are 10, 200. It will become 1 over 200. Miss Aisha, question number 2E. What will be the answer? So 10 to the power minus 2, what would it be? You don't use calculator. So you have 100, 10 to the power minus 2. If I move it to denominator, it will become 1 over 10 squared or 1 over 100. 10 to the power minus 2, when it goes to the denominator, the power would become positive, right? So 10 to the power 2, which is 100, so 100 cancels 100. The answer would be 1. Also, you could have said that this 100 is 10 to the power 2 multiply by with this 10 to the power minus 2. So you would know the answer is 1. Okay, Sir Arman, 1F, sorry, 2F is easy. So 2F would simply be moving 10 to the power minus 3 to the denominator. It will become 1 over 10 to the power 3 or 1 over 1000. Okay, Sir Arman, question number 3A. What's the answer? Miss Noor, question number 3A. What is the answer? 1. So it will be 9. 3 to the power minus 2. I'll move it to the denominator. It will become 3 squared or 9. So 9 by 9 will be equal to 1. Miss Aisha, question number 3B. What will be the answer? Where did you get 0.125 from? You shouldn't be using the calculator, number 1. And number 2, 2 to the power minus 3. I move it to the denominator. It becomes 2 to the power 3. Alhamdulillah. So it will become 2 to the power 3. 2 to the power 3 is 8. So 16 divided by 8, which is 2. Okay. Miss Noor, question number C. 3C. Miss Aisha, question number 3C. And 2 to the power 4 is? 2 to the power 4 is 10. Excellent. 2 into 2 is 4. Into 2 is 8. Into 2 is 16. So 64 divided by 2 to the power 4 is 64 divided by 16. 16 ones are 16. 16 fours are 64. So 4 will be the answer of this one. Okay. Sir Arman. जी. You get questions for the certain questions on your exams which you have to do without calculator. You must know how. Hmm. 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 Mm, you could, but you could also save time and not use it. Acha ji. Sir Arman, question number 3D quickly. 3D. All right. Miss Noor, question number 3E. Miss Noor, question number 3E. 3E. Yes, please. 1 over 6. So 36, I can write it as 6 squared. And 6 to the power minus 3, I move it to denominator, it becomes 6 cubed. Then if I move this 6 squared to the denominator, its sign, its power, it will become negative. So 6 to the 6 cubed multiplied by 6 to the power minus 2, it will become 6 to the power 1. So in denominator, I have 1 over 6 to the power 1 or 1 over 6. Miss Aisha, 100 into 10 to the power minus 1. 1. How? It will be 100. 100 divided by 10. 10 to the power minus 1. In denominator, it will become 10 to the power 1. Alright. Good job, Miss Noor. 10 would be the answer. Okay. Sir Arman, question number 4A. 12. Excellent. Miss Aisha, question number 4B. So 4 into 2 to the power 3, 2 to the power 8. 8 fours are 32. Good job. Miss Noor, question number C. 4. Excellent. 225. Shri Sir Arman. Question number 4D. 4 squared is 16. 16 fives are 80. Excellent. Miss Aisha. Question number E. 7 to the power minus 3 into this one. I'm moving to the numerator, so that the one that's already in the numerator stays like that. So it will become 7 to the power positive 4. So 4 minus 3, it would be 1. 7 to the power 1 or 7. Miss Noor, question number F. Excellent. 8 to the power minus 6 multiplied by 8 to the power 8, which is 8 squared, and 8 to the power 2 is equal to, Miss Noor? 64. Okay. Okay, now the next exercise is till now we are given what the power is equal to. What if power is the unknown value that we have to find out? Okay, and this is the perhaps the last type of questions that we would practice tonight. Challenge. Just a second. Hmm. नहीं 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 नहीं. There are more to go about. Did we skip any in between? हाँ जी, we did skip. अच्छा, अच्छा. Um, ठीक है. Let's quickly do this question number 4 and then we'll get to the next type. All right. Question number 4. Miss Aisha, answer to part A, please. All right. Challenge, try to beat me, solve it faster than me. Miss Noor, question number 4B, please. All right, Sir Arman, question number 4C, please. Excellent. Miss Aisha, question number 4D. I wait. add we add 10 and 2, so it becomes 4 to the power 10 into 4 to the power 2 into 4 to the power minus 7, because 4 to the power 7 is currently in denominator. It comes to the numerator, it becomes negative. So 12 minus 7, it's 5 these days. Miss Noor, question number 4E. Calculator. 2 to the power 2. So this would be 64 times 4. 256, you say? G. Anybody who's getting an answer other than 256? No one. Sir Arman, question number 4F. What's the answer? Okay. For this one, we can leave it in this index form. The answer is the number. Yes, it would be really big, but it should be something 6 to the power 4 times 8 to the power 5. Okay. Miss Aisha, 1600. All right. So the way we 5 to the power 10, it will become multiplied by 4 to the power 12 into 5 to the power minus 8 into 4 to the power minus 9. So 10 minus 8 is 5 squared times 4 to the power 3. So 25 times 64. Hmm, good job. अच्छा जी, Miss Noor, part H. So 6 to the power 7 times 4. Anybody getting a different answer? 6 to the power 12, correct. Then, so let's just first write the powers of all the numbers. 6 to the power 3 stays as it is. 4 to the power 9 stays as it is, right? This one will become 6 to the power minus 8 once it comes to the numerator, and this one will become 4 to the power minus 8, right, Miss Noor? And then for 8, I will add 12, 3, and minus 8, that gives me 7. And for 4, I'll add 9 and minus 8, that will give me 1. All right. This, then the final type of questions. The final type of questions, chale, this one inshallah we'll do in the next class, or let's see. Nahin, let's do one from each of them right now. Let's see where to do it. Yeah, let's do it in the next class. This one, let's do it in the next class. It's a slight bit different. All right, see you in the next class, everyone. Assalamu alaikum. Homeworks I'll send in a bit. It's time for my next class right now, my other class. So I'll send in a bit. Walaikum assalam wa rahmatullah.